Hello everyone. What I wanted to do in this video is give you a review of some of the items on the review sheet that I posted on Blackboard. Notice that they are posted on Blackboard and the solutions are also posted. There are some problems that are a little different from any type of example that we did in class, and I wanted to focus or highlight on some of those problems. And so this video contains problems that may be a little different from stuff that we did in class. These are not necessarily the most difficult items, but these items are a little different. All right. And so I'm not going to do many problems. I think there are about 5 problems that I'm going to go over here. And then you take the time to go over the rest of the problems that are on your review sheet to help you prepare for your exam. All right, let me figure out where this problem is. All right, I'm going to start with problem number 4. It says to complete the table of values for the linear function, write the equation of this linear function. And this is stuff from section 1.2. All right. So in this example, we see our x values and our f of x are our y values, right? You know, y equals f of x, right? And so as you can see, each time, each successive, the next x value, they're equally separated. In order to go from one x value to the next, we always add 4, right? So our x's are evenly spaced. So if I want to fill in this chart, my y's should also be equally spaced, meaning I add the same number or I subtract the same number in order for me to get to the next one. All right, and I know that because we have a linear function here. And so for me to go from 6 to 10, that is an addition of 4 units, which is the same as x. That's not always the case, but hey, this happens here. And so for me to get to the next y value here, I have to add 4 to 10. So I had to get a 14. Add 4 to that, I get 18. Add 4 to that, I'd get 22. All right, and so now that we've filled in the table of values to make this a linear function, we want to rewrite the linear function as a formula or whatever. And some of you probably can look at this and tell what the linear function is, all right? Remember, the definition of a function is where you put one input into the function and your function would output one and only one output value, right? So for instance, here, if I look at this point here, I plug in 4 into my function, I get 6. I plug in 8 into my function, I get 10. Plug in 12, I get 14. If you notice, the y value is always 2 more than the x value. So, I mean, if you really wanted to write the function, you can say that y, if you don't want to write, you can say f of x as well, okay, equals whatever I input plus 2. Okay, and that will be your linear function. Now, just so that we get a review of our actual formulas for writing the linear function, our equation of a line, I'm going to go through the process, right? Remember, you can use y equals mx plus b, and you can also use the formula y minus y1 equals m times x minus x1. Just for fun, since we've done this one so many times, I'm going to stick to using y minus y1 equals m times x minus x1, just so we get a review. Remember, for this equation of a line, we need the slope, and we need a point, x1, y1. All right, we got to figure out what that equals. So I'm going to first start by finding the slope. All right. Your slope is your change in y over your change in x. From this thing here, we can see that, hey, when my x is changed by 4 units, my y also changes by 4 units, right? So if I were to do just change in y over change in x, looking at that table, I'll do 4 over 4, which is 1. And that'll be my slope, right? If you don't want to use the table, then you can go and use your choose your 2 points, right? So I have 1 point is 4, 6. My other point I can use is 8, 10. And then remember, the formula for your slope is f of x2 minus f of x1 all over x2 minus x1. And so I'll plug those values in, right? This right here, this 10 will be my f of x2. That's a y value. The other y value is 6. So I get 10 minus 6 over 8 minus 4. That's that 4 over 4 again, which is the 1. All right, so I know that my slope is 1, as I have here. And then I just choose one of my points to be my x1, y1. I'll let that point be 4, 6. It doesn't matter which point you use. But then I'll put those values into this formula here. I get y minus y1, which is 6, equals 1 times x minus 4. That's a y minus 6 equals 1 times x is x, 1 times negative 4 is negative 4. So I get x minus 4. And then I'd add 6 to both sides. I get y equals x plus 2. Negative 4 plus 6 is a positive 2. And so if I want to write it in as an f of x, a function of x, I get f of x equals x plus 2. Okay? So I just wanted to fill in that table and come up with use the equation of a line to come up with the function. All right. Now what I want to do is I want to look at problem number 7. It says the total cost C of producing X sneakers is given by the function C of X equals 0.01 X squared minus 0.2 X plus 2,000. Find the average rate of change in the cost if production is increased from X equals 100 to X equals 150. All right, you want to remember that we have average rate of change. Remember, slope is rate of change, right? And when we have a line, our slope is constant. When we have a curve or, a graph that is curvy, we can't necessarily find the slope like we normally would using just basic algebra. That's going to be the topic of our next chapter when we get into calculus. All right. And so right now, what we're going to do is we're going to kind of look at the slope of the secant line. Remember we said in class that, hey, if I have something curvy and I want to find like the slope between 2 points, then I have to draw the secant line. That's the line that passes through those 2 points. I know that's kind of curvy. And we'll let our average rate of change be the slope of that line, right? And so our average rate of change formula looks almost identical to our slope formula, right? So we have this right here. Now, if I wanted to be very particular here, I can use this in terms of C, which is the variable our y values are given in terms of. So I can put C here instead of F. And I'll just go ahead and do that. So C of that stuff. All right. And so my X2 is that 150 here. So this will be replaced by 150, and then C1 will be replaced by 100. And so I'm going to get C of 150 minus C of 100 all over 150 minus 100. Okay? Now in this case, we're not looking at a table. We're going to use the formula for this function, which is here, in order to help us do that, right? So I'm going to come off to the side over here, and I'm going to find out what C of 150 is, right? Remember, all you got to do is plug in 150 for X. So I'm going to get 0.01 times 150 squared minus 0.2 times 150 plus 2,000. And that equals, I already did this, 2,195 if I'm not mistaken. And then I'll plug in 100 for X. So 0.01 times 100 squared minus 0.2 times 100 plus 2,000. And I get that is about 2,080. Okay? And so my average rate of change, all right, let's draw this, equals 2195 minus 2080 all over 150 minus 100. And so if I simplify that, I'm going to figure out that is approximately, it equals 2.3. And then my units is going to be my C, which is the cost, the total cost of producing, which is going to be dollars. I'm going to assume it's dollars here. And then my X is my denominator here, right? And it's X sneakers, so it's going to be per sneaker. Okay, so on average, when I increase production from 100 sneakers to 150 sneakers, the total cost of producing the sneakers in total is going to increase by $2.30 per sneaker. All right, for each additional increase in sneakers, the price or the total cost is going to increase by $2.30. Okay. Let's look at our next example, which is problem 10. It says, suppose an account earns, I'm going to change the color. This is nice. Suppose an account earns interest at an annual rate of 9%, compounded continuously. Oh, there's a keyword there. Nice. Determine the amount of money grandparents must set aside at the birth of their grandchild if they wish to have $20,000 by the grandchild's 18th birthday. All right. When I see this here, this compounded continuously, I automatically know that I'm going to use the formula P of T equals P naught times E to the R times T, right? And so what I want to do is I want to figure out, okay, the thing that I want to find in the end is the amount of money the grandparents must set aside. That means the amount of money they're going to deposit. So that means this is what I want to find. All right, P naught. We hadn't done an example in class like this, so I just wanted to go over this. All right. They give us the other variables here. I know that R, so I'm going to come off to the side, R equals 0.09. And I know they want $20,000 by the grandchild's 18th birthday, right? So I'm going to have T equals 18. And what they're saying with this 20,000 here is that when T equals 18, so I can put 18 into my function, I want it to spit out 20,000. That's what I have here. And so I'm going to put this information into my function. So I'm going to have 20,000 equals, I don't know P naught, that's what I'm trying to find, times E to the 0.09 times 18. If I want to solve for P naught, I'm going to divide both sides by E to the 0.09 times 18. You can put that in your calculator and simplify it. I put the decimal approximation, but I'm going to just put it in my calculator all at once so I don't have to approximate anything, okay? And so I get that. Notice that on the right-hand side, the E to the 0.09 times 18, they cancel. And so I'm going to end up being left with P naught here equals this thing put into my calculator. And you're going to get approximately $3,957.97. Okay. Now, depending on rounding and all that stuff, we might round up to 3,958 or whatever. But this is what I get to the nearest cent. All right. And so that's how much they should invest. So they probably put like $4,000 in there. And then if they maintain this interest rate for 18 years, their grandchild would have $20,000 in the account. That's amazing. All right. Let's go to the next example. All right. Number 14. You might have had an example like this on your homework, but I want to look at this one as well. All right, it says the following gives the supply and demand curves for a certain good. All right, it says, why is the supply curve increasing as you move from left to right? So my supply curve is this curve right here, right? And it's increasing. And remember, we said in class that quantity is a function of price, right? And so normally we would write price over here and quantity over here. But historically, economists thought that quantity was a function of price. And so they used this type of graph here, or the setup for your axes. But when they changed that idea, they didn't put P over here like it should be, and they didn't put Q as the vertical axis like it should be. All right, and so it's a little weird to think about sometimes. But the reason why the supply curve is increasing is because as the price increases, right? Price increases is here, right? As the price increases, meaning our graph goes up, our quantity should also increase, right? Sellers want to sell the most products at the highest price, basically. And so as price increases, so does the amount of product that the seller wants to sell, right? That's why it's increasing. All right, and so let's go to part B. It says if the price is this should be an IS here, is $50 per item, the producers will supply blank number of items, right? So remember, our price is on this vertical axis, and 50 is right here. That's a price of $50. And so if I go to my